Hi. During this part of the lesson, we're going to be looking at conservation of momentum. And so previously in this specific lesson, we've done, as to do it now, a review of momentum, how to calculate it, and also a short little inductive lesson on a lesson segment on learning about conservation of momentum. So we sort of derived that during the inductive section. And we did that by utilizing cars like these. They broke up into groups, collided the cars, and made observations. Then we discussed those as a class and derived conservation of momentum based on that. So now we're going to do an actual experiment based on conservation of momentum, and we're going to take actual measurements and confirm it for ourselves. And so we're going to do that by doing a little experiment. We're going to use a motion detector and two cars. We're going to do an inelastic collision. So let me show you the setup. Here's the motion detector, and here are the two cars. They roughly weigh about the same. I unfortunately don't have an actual digital scale, so I'm going based on picked cars that felt about the same weight. They have Velcro attached to them. So we're going to do an inelastic collision here. Ideally, I would like to have a track and a slope down to where the collision takes place, but unfortunately, I actually just don't have that, so I'm going to be utilizing my hand to do this, and we'll be taking measurements, looking before and after the collision, and making observations. Okay, so before that actually takes place, I'm going to have the students break up into groups and take a look at what they think will happen when the cars collide, when we actually do the experiment. So they're going to make predictions and make graphs based on those predictions that we are going to look at, and they'll include, they'll hand it at the end of class. So as they break off into groups, I think groups of 3 would be appropriate for this. They're going to break off and discuss it, and I'm going to walk around and ask them questions, like what happens to the velocity specifically, because, that's a component of momentum that they want to look at. We already know the mass of the cars because we would have measured it with scales. But so I'm going to around and ask what happens to the velocity before and after the collision, and how that would affect the momentum based on our previous discussions on momentum. And then we'd come up and discuss it as a class real quick, make predictions, and we draw. That's one of the nice things about Loggerlight is you can actually draw your prediction out, and so we do that as a class, and then we would get to doing the actual experiment. So here's what the actual experiment will look like, provided normally in class there would be a track. That. And that produces data that looks a little bit like this. So this is the data generated by that, and on this graph you can see I've put position, velocity, and acceleration, but as you can see, as the students will be able to see, it's hard to tell what is what because everything's red. So this would be a good opportunity, if they haven't seen it yet, to go in and show them how to manipulate this. And specifically, I mean, if you go to velocity, column options, click latest velocity. So you can change the color. So we'll change that guy to blue. Done. And now you can see which one that is. Position will leave red. And acceleration, we're going to go in. Data options, column options, latest acceleration. And we'll make this guy green. Alright. And now we can see the data a bit more clearly, and we're going to go over that as a group, and we're going to take a look at how this matches up to our predictions. But what we're really going to look at, so we're going to look at, this acceleration, I'm going to ask them what that acceleration corresponds to, and that'll be me accelerating it with my hand, and then what this steep deceleration corresponds with. So you have some deceleration going on here, which is just after it leaves my hand before it collides. And that's just due to friction. But then you have this steep deceleration here. And keep in mind, green is acceleration, right? Yep, so the steep deceleration. And you can see that play out in the velocity data as well as it starts to decelerate, as it starts to lose velocity. So that is corresponding to the actual collision. Okay? And that's a question that I'll ask and suss that out of him. So looking at velocity on either side of this, we're going to take the points of data on either side of the collision. Should be, here's the maximum velocity of the car. And then if we look, here's the end of the collision, right? So right in here, we would take these data points. And using the mass of the cars, we would take those values and use them to calculate the momentums and see if they compare. And if they don't, we'd look at reasons why they wouldn't. And ideally, we'd look at friction would probably be the main reason. Would be the main reason that we would examine. And so, just roughly looking at this, we have our velocity at this point is about 0.68. So 0.681. Right here is at the end of the collision. The velocity is 0.5. And down here is 0.389. So let's take this data point and that data point. And if we assume that the car's velocities are, not velocities, the car's masses are roughly the same, then here we'd have one car mass times the velocity, 0.681. Here we'd have, so that would be 0.681 kilogram meter per second. And here we'd have 0.389. So you can see that normally if the car's masses are exactly the same, then this would be double the mass but same momentum, so you'd have half the velocity. And it's not quite half, but it is close. And in the class, I would ask them, and we'd examine why there was a discrepancy there. And there are a number of reasons, specifically in this setup where it's very low tech. But yeah, user error is a big reason for that, because I just don't have the track and the components right now. But yeah, that is the lesson that I would do. All right, thank you very much.